Hello, you are welcome to the channel Physics for Everybody. Today we'll be talking about resistors in series and parallel under the topic electricity. How do you distinguish between resistors that are connected in series and in parallel? If you look at this diagram, these resistors are considered to be connected in series because there is a single loop in this circuit. In this particular electric circuit, there is a single loop, and this is a single loop. So it's just like you have a single wire that joins this resistor to this one and to this one. Okay, so a single conductor goes from the positive terminal of the battery. Okay, in this case we have a cell, okay, because we have one here. So it goes from the positive terminal of the cell, it goes to the first resistor, it comes out from the other end to the second resistor, comes out from the other end to the third resistor, comes out from the other end of the third resistor and back to the cell. So if you want to find the effective resistance in this circuit, this is the positive terminal, this is the negative terminal, okay? The cell supplies an EMF of 1.5 volts. The full meaning of EMF is electromotive force, and it is measured in volts. This volts is just its SI unit, okay? EMF means electromotive force. So, how do you find the effective resistance when you have resistors connected in series? Now, this is the formula. You say RE, you use RE to represent the effective resistance. So you just say RE is equal to R1 plus R2 plus R3. You just take the sum of all the resistors, and that gives you the effective resistance. Let us take an example. Let us assume the resistor R1 has a value of, let us assume R1 has a value of, let me use 3 ohms. 3 ohms. R2 has a value of 3 ohms. R3 has a value of 3 ohms. How do you find the effective resistance? You use this formula. RE equals to R1 plus R2 plus R3. Let's solve this. Let us add. R1 is 3 ohms. 3. Okay, I think this is not clear. Let me make it clear. R1 is 3 ohms, R2 is 3 ohms, and R3 is 3 ohms. Now let's solve. R1 is 3 ohms, so you have 3, plus R2 is 3, plus R3 is also 3 ohms. 3 plus 3 plus 3. That means our effective resistance is 9 ohms. Now, if the question asks you to find the current flowing in the circuit, okay, let's assume the question asks you to find the current flowing in the electric circuit. How will you do that? Let's assume the question asks you to find the current. Let us write it here. Find the current flowing in the circuit. Which law would you use? We use Ohm's law. And according to Ohm's law states that V is equal to IR. That means voltage equals to the current multiplied by the resistance. Which resistance will you use? That is the effective resistance, RE. Now let us solve this question. Find the current. This is the formula we use to find the current. V equal to IR. What's the voltage? The voltage is the EMF supplied by the cell, and which is 1.5 volts in this case. What is the current? Current is what we are looking for. Find the current flowing. What is the resistance? The resistance is the effective resistance in the circuit, which we have calculated as 9 ohms. Now we can solve the problem. Let us substitute. The voltage is 1.5 volts, 1.5 equals to I. What's the current? Current is what we have to find, unknown. current multiplied by the resistance. The resistance is the effective resistance of the circuit, which we have as 9 ohms. In this case, how will you find I? Let me just finish this calculation here. If 1.5 is equal to I multiplied by 9. To find I will divide both sides by 9. 9 will cancel out 9. I'll be left with I here. So I is equal to 1.5 divided by 9. 1.5 divided by 9, what would that give you? That gives you 0. Hold on. 3 here, 3 here, 50. 50 divided by 3, that gives you 16.67 amperes. 16.67. So 1.5 divided by 9 will be 0.1667 amperes. You can write it to 3 decimal place. 0.167 amperes. That is it. Easy. We can modify this circuit. What if the circuit does not have 3 resistors? No, we are through solving this question, okay? And if the question asks you to find the current flowing through the R3 resistor, the same current flows through the entire circuit. That is one thing about series circuits. You see, there is a single loop through all the resistors. So if you have to find the current in this resistor, the current in this resistor is the same thing as the current in this resistor, and it's the same thing as the current in this resistor. So series circuit, the same conventional current flows through the entire circuit, okay? And what's the value of the current in this case? That current is 0.167 amps. So 0.167 amps flows through the entire circuit. We have 0.167 amps flowing through R1. That same current flows through R2. It flows through R3. It goes to the cell, okay? Comes out here and it keeps flowing. And do not forget that if conventional current is flowing from positive terminal through the circuit and back to the cell through the negative terminal, that simply means electrons, okay? The electrons, that's the charged particle. Electrons are going out of the cell from the negative terminal. They flow through the circuit and return to the cell through the positive terminal. So electrons are going in the anticlockwise direction, while conventional current is flowing in the clockwise direction. That is one common thing about all electric circuits. The direction of conventional current is opposite the direction of flow of charges or flow of electrons. And conventional current always flows out of the cell from the positive terminal. Okay, it goes out from the positive terminal, goes on the circuit, goes back to the negative terminal. While electrons comes out from the cell from the negative terminal, flows to the circuit, and returns to the positive terminal. Okay, so that is one thing about series circuits. Let us modify this question to solve another example. Let us assume we have just 2 resistors. If you have just 2 resistors in the circuit, how will you solve it? Okay, let's also change our resistors to, let's put another value, like let's assume this is 2 ohms and this one is 4 ohms. Okay, let's assume we have 2 cells. Okay, so now we can say we have a battery. So the EMF here, if you have 2 cells, our EMF can be, let's assume our EMF is 3 volts. Find the current flowing in the circuit. I want to modify this question. Find the current flowing through the 4 ohms resistor. Okay, here I am asked to find the current flowing through the 4 ohms resistor. So I've been asked to find the current in this resistor. How will I do it? Take note that since it is a series circuit, then the same current flows through the entire circuit. So whichever value I get for the current flowing in the circuit, that same current will flow through the 2 ohms resistor and it will also flow through the 4 ohms resistor. That is one common thing about series circuit. In the case of parallel circuit, then the current will split. What do I mean? In the case of parallel circuit, let's assume I have 9 ohms flowing. If I have 9 amperes, current is measured in amperes or amps. So if I have 9 amps flowing from the positive terminal, if it gets to this branch, then the current will split. Okay, the current will split. Okay, into different values and flow through each of the 3 resistors. That's for parallel circuits. I will still talk about parallel circuits in detail. But for series circuit, the same current flows through all the components of the circuit. So instead of finding the current through the 4 ohms resistor, let me just find the current flowing in the circuit. Okay? And then I'll say that same current flows through the 4 ohms resistor. How do I find the current flowing in the circuit? I have to calculate the total resistance in the circuit. After calculating the total resistance, then I will use Ohm's law. V equals to I R. So once I get my effective resistance, okay, you call it effective resistance or you call it total resistance. Once I get my effective resistance, then I use Ohm's law to find the current, okay? Take note, I have the voltage as 3 volts, okay? So if I get the effective resistance, then I will use this to find the unknown, which is the conventional current. How do I find the effective resistance in a series circuit? Let me solve it. Solution. The effective resistance in a series circuit is the sum of the 2 resistors. If you have just 2 resistors, you add them together. If you have 3 resistors, you add them together. As long as it is a series circuit, just add all the resistors together and you get the effective resistance. Let's go. R1 is 2 ohms, R2 is 4 ohms. I will add them together. So my effective resistance is 2 plus 4, and that gives me 6 ohms. Now, I want to use Ohm's law to find the current flowing in the circuit. How will I do that? According to Ohm's law, V equals to I R. What's the voltage? My voltage is 3 volts. 3 equals to... What's the current? The current is the unknown. The question says find the current. So I don't have the current, I write it as the unknown multiplied by R, okay? Multiplied by, what's my R? The R is the effective resistance, which is 6 ohms. So if I have this, how do I find the value of I? I will divide both sides by 6, okay? Yeah, so 3 is equal to I multiplied by 6. I will divide both sides by 6. 6 will cancel off 6, okay, so I have I. 3 divided by 6 is 0.5. That simply means the current flowing in the circuit is 0.5 amps. And that is equal to, that's the same thing, okay? So if I have 0.5 amperes flowing in the circuit, that 0.5 amperes will flow through the 4 ohms resistor. So you just state that the current through the 4 ohms resistor is 0.5 amps. Easy? Yes, it's always as easy as this. What if you are talking about parallel circuit? You know, the topic is series and parallel circuit. We have talked about the series circuit, and now you want to talk about the parallel circuit. In the case of the series circuit, you know, we have a single loop. A single loop. That means one single conductor. Okay? What about the parallel circuit? There are branches in the parallel circuit. That means in the electric circuit, okay, this is the cell. We have one conductor, and the conductor goes this way. On getting to this place, there will be a branch, okay? The conductor will split up. the conductor will split up into different branches. So if we have a conventional current, this is positive terminal, this is negative terminal. If you have the current flowing this way, on getting to this junction, the current will split. The current will split. Okay, we can have I1 flowing through the R1 resistor. We can have I2 flowing through the R2 resistor. Then we have I3 flowing through the R3 resistor. This is what happens in all parallel circuits. So the current in the circuit splits. Okay, it splits here. We have I1 flows through R1. We have on getting here I2 will flow through R2. Then the current on getting here I3 will flow through R3 and then return. Let us assume these three resistors are of equal value. Let's assume we have 2 ohms resistor here. Let's assume R2 is also 2 ohms. And let's assume R3 is also 2 ohms. Since the three resistors are equal, that means the current that is coming from the cell will split into 3 equal values. Why? Because the 3 resistors are of equal values. So if the current flowing from this cell is 6 amps, then let me use 6. I don't want to get the same value with the resistor. If the current flowing from the circuit is 12 amps, that means this 12 amps will split into 3 equal values. Okay? Yeah, if we divide 12 into 3 equal values, we get 4 amperes. So that means 4 amperes will flow through the R1 resistor, 4 amperes will flow through R2 resistor, then 4 amps will flow through R3 resistor. So I1 goes this way, I2 goes this way, I3 goes this way. So the 3 currents will add up here again and then return to the cell. So that is what happens in every parallel circuit. Okay? So the current comes out from the cell, splits up into 3 values. Those 3 values will combine again at this end and return to the cell. So if you have 12 amps coming from here, it splits into 4, 4, and 4. Okay? Then here, the 4, 4, and 4 will combine to form 12 amps, and 12 amps return to the cell. And that cycle continues. Take note that Ohm's law will always be obeyed. V equals to I R, where the resistance is the what? The effective resistance of the circuit. I is the current, V is the EMF supplied by the cell. Let us solve an example. Take note that in this case, to find the effective resistance, this is the formula we'll be using. 1 over effective resistance equal to 1 over R1 plus 1 over R2 plus 1 over R3. Let us have an example. Let me remove this circuit and draw again. Now, in this case, you have to calculate the current flowing through the cell. Solution. Here we have to calculate the current flowing through the cell. What is the current flowing through the cell? That is the current I. Now take note that the EMF of the cell has a value of 3 volts. So the current that comes out from the cell, okay, here, the way I do it, I put the positive terminal here, I put the negative terminal here. Don't forget that the long side, the long bar represents the positive terminal, while the short bar represents the negative terminal. So that means the current will come out of the cell, okay, and then flow through the resistor. It splits here, current flows here, current flows here. Then it combines here, and then it flows through the cell. What does that mean? That means the total current I, that is what flows through the cell, okay? The current splits up here, then it combines here and flows through the cell. How do we get the total current flowing in the cell? We use Ohm's law. V equals to I multiplied by RA. How do you find RA? This is the formula we use. Let us find RA. Now let's go. 1 over RE equals to 1 over R1 plus 1 over R2 plus 1 over R3. Let me clean this place so I can have enough space to solve. Okay, so we are looking for RE. Let's go. 1 over RE, which is our effective resistance, equals to 1 over, what is R1? R1 is 2 ohms. Plus 1 over R2. What is R2? R2 is 2 ohms. Plus 1 over R3. What is R3? R3 is 2 ohms. Now let's solve this. So we have 1 over RE equals to 1 over 2 plus 1 over 2 plus 1 over 2. That should give you 3 over 2. Okay? An easy way out. What's the LCM of 2, 2, and 2? The LCM of 2, 2, and 2 is 2. Okay? Then you add the numerators. 1 plus 1 plus 1, you get 3. Why did I add the numerators? Because they all have equal denominators. So we have 2 here as the denominator. Half plus half is 3 over 2. Easy. So 1 over RE equals to 3 over 2. How do I find RE? I can easily cross multiply. Multiply these 2. RE multiplied by 3. I'll get 3 RE. 2 multiplied by 1, I'll get 2. So to find RE, I'll divide both sides by 3. Divide it by 3, divide it by 3. That means RE equals to 2 over 3. The 3 cancels out 3 here. So that is my effective resistance. 2 over 3. Now let me use Ohm's law to find the current in the circuit. What is Ohm's law? According to Ohm's law, V is equal to IR. From Ohm's law, V is equal to IR, where V is the EMF supplied by the cell, which is 3 volts. I is the current which we are looking for. Calculate the current. R is the effective resistance of the entire circuit, which we have as 2 over 3. So let's go. We have 3 volts as V. 3 is equal to I multiplied by 2 over 3. Okay? Our R is 2 over 3. Our V is 3 volts. What will you do here? Let's multiply. 3 is equal to I times 2. That will be 2I over 3. So what I can do is introduce a denominator of 1 here and cross multiply. 2I multiplied by 3. That's 2I. 3 multiplied by 3, that is equal to 9. So how do I find I? I will divide both sides by 2. Okay, so if 2I is equal to 9, then I'll divide both sides by 2. 2 will cancel out 2, I will have I is equal to 9 divided by 2, I'll get 4.5. That is the current flowing in the circuit. Now, what if the question asks you to find the current flowing through each of the resistors? What if the current asks you to find the current flowing through R1, R2, and R3? You know, since the 3 resistors are equal, then just divide the current by 3, and that will give you the current flowing through R1, through R2, and through R3. Okay, so my answer is my current I divided by 3. If I divide 4.5 by 3, what will I get? I will get 1.5 amperes. Okay, yes, 1.5 amperes. That is the current flowing through R1. 1.5 amps will flow here. R2, 1.5 amps will flow through R2 as well. And R3, 1.5 amps will flow through R3. And that 1.5 current is flowing from positive terminal, right? So 4.5 amperes, which is the total current in the circuit, 4.5 amperes will flow and get here. On getting to this place, the 4.5 amperes will split into 3. It is split into 3. So the 4.5 amperes will split into 1.5, 1.5, and 1.5. So that's 1.5, 1.5, and 1.5. They will all recombine again. They will all recombine here, okay? So we have 4.5 amperes flowing back to the cell, and the cycle continues over and over again. Some other examples will be solved in the next video. Thank you for watching. Do have a nice day, and sure you subscribe to this YouTube channel. Thank you.